Let's begin by going over the 6 types of reactions that we've covered so far. The first one is synthesis. In a synthesis reaction, 2 reactants, we'll call them A and B, combine to form the third product, AB. A and B can be either elements or compounds. A and B is always a compound. The second is decomposition. Decomposition is when a compound breaks down to become 2 smaller compounds or elements. The third, single displacement, is when one substance combines with a compound and one of these takes the place of one of the parts of that substance, kicks the other one out. In double displacement, the 2 parts of 2 compounds switch places. So A switches places with C, or B switches places with D. We end up with this. In combustion, we have a hydrocarbon of some kind with some numbers of C's and H's, possibly some O's, and oxygen gas, and it reacts to form the products carbon dioxide, or CO2, and water. And in the last reaction, an acid-base reaction, or neutralization, we have an acid, which I'll just call HA, plus some base, which I'll call BOH, and they react to form a salt of the acid with the metal in the base. So this is a salt of some kind, and the H and the OH combine to form HOH, otherwise known as H2O. Now, let's go look at our homework assignment. In our homework assignment, our first reaction, we have Ag2O yields Ag plus O2. So we start with a single compound, and we end up with 2 separate elements. So this is clearly a decomposition reaction. Let's take a look at the balancing. Here we have 2 Ags, 2 silver atoms, but only 1 over here. So I would start by putting a 2 in front of this in order to fix that. However, when I try to balance the oxygens, I notice that there's 1 here and there are 2 here. This can almost always be fixed when there's an odd number on one side and an even number on the other, just by doubling this number in front. So now I have 2 times 2 silvers, which means I need to change this to 4. I have 2 times 1, which is 2, and I have 2 here. So a 1 here. Normally we don't write 1s in chemistry, but I'll just write it here. And that's the answer. Let's look at the second one. In the second one, barium chloride reacts with H2SO4, which is sulfuric acid, to produce HCl, which is hydrochloric acid, and barium sulfate. If we look, we can see that both of these are compounds and both of these are compounds. We can also see that there's a positive and a negative part of this compound and a positive and a negative part of this acid. In this case, the H's and the BA's have switched places here and here. So since we have 2 compounds which make 2 new compounds, this is double displacement. Or double replacement, depending on the text that you read. Now to balance. First we'll look here and we count the number of bariums. There's one barium here and there's one here. So far so good. Come back over here and we see that there are two chlorines, but there's only one here. So to fix that, I'm going to multiply this compound by 2 by putting a coefficient in front. Come back over here and we see that we have two H's, and since we had already put a 2 here, we have two H's here. So that's good. We can balance the sulfurs and the oxygen separately, but if we note this is a polyatomic ion, we see that it's still a polyatomic ion here, meaning it hasn't broken down. So we can balance this as a whole unit. We see that there's only one here and there's one here. So this equation is balanced with just having added that 2. Let's look at the next equation. The next equation, I have CH4, otherwise known as methane, plus oxygen yields CO2 and water. The fact that we have a hydrocarbon and oxygen as reactants and carbon dioxide and water as products indicates that this is a combustion reaction. In order to balance it, first I'll look at the number of carbons. I see that there's one here and there's one here. So far so good. Here I see that there are 4 hydrogens, but there are only 2 on this side. So in order to fix that, I'm going to multiply this number by 2. Now I have a total of 4 hydrogens on this side. 2 times 2 is 4 to balance the 4 here. Lastly, I'm going to balance oxygen. Oxygen is best balanced by doing it backwards, meaning from products to reactants whenever we have a combustion reaction. So I'm going to count the total number of oxygens in the products. There are 2 products that contain oxygen, carbon dioxide and water. So I have to count both of them. There are 2 oxygens here, and 2 times 1 for the water is also another 2. So there are a total of 4 oxygens in the products. If I come over here, I see that oxygen is always in pairs in a combustion reaction, and I need 2 pair in order to equal the 4 on the other side. And this reaction is now balanced. In question number 4, I have one compound here, calcium oxide, and a compound here, silicon dioxide, and they can combine to form calcium silicate. The fact that there's only one product and there are 2 reactants indicates that this must be a synthesis reaction. If I count the number of calciums on this side, I see there's only 1 and there's 1 here. So far so good. Oxygen appears twice, so I'm not going to count it yet. I'm going to look at the silicon, and I see that there's 1 Si here and there's 1 here. Again, so far so good. And lastly, I'll balance the oxygen. I'll do it the way I do with combustion, which is backwards, and look at this number first. There are 3 here. On the other side of the equation, there are 2 plus 1. So this equation is already balanced. Let's take a look at number 5. In number 5, I have aluminum, that would be just the metal by itself, combines with iron 3 oxide to produce iron and aluminum oxide. Because I have a free element here and a compound, and I have a free element here and a different compound, it appears that the aluminum has taken the place of the iron in this compound to yield the aluminum oxide. When one element comes in and takes the place of another, we call that single displacement or single replacement, depending on your text.